Hello everyone, myself Ritu Singh from Lakshmi Institute of Technology, Sarega. Today I am going to have one chapter of irrigation engineering, that is computation of irrigation efficiency. So here what we are going to do, how we can compute the efficiency of irrigation, okay, and we will going to solve the few numerical based on this efficiency. So before we need to understand the soil strata, the soil aeration. So this picture is having the soil and you are having one plant. You can see here the roots over here, microorganism which is helpful to the growth of the plant. We are having CO2, this oxygen supply, CO2 hydrosalinating, and the soil surface. This soil aeration is primarily a process of O2 and CO2, oxygen and carbon dioxide exchange between the air phase of the soil and external atmosphere. Okay. So this is how we are irrigating our land. In your home also, in your balcony, you have placed mini pot. So you need to understand this in the macro level from your home, than your agricultural land. So this is having, suppose this is a root things, and in the nursery itself, from the first standard itself, you have been taught that the plant needs air, water, soil for its growth. So here you can easily understand this. This is mineral aggregate over this. This is root of the plant, soil particles, water, air. So these things we need. If your area is waterlogged, is saturated, means air is not present, then also your plant will going to die. Okay. So this is a strata of the soil. Like if your proper drainage is there, promotes healthy roots yielding greater crop production. Okay. If your soil having proper drainage, okay, so this is like spring season and this is summer season, the undrained land where your land is not drained. Okay. Here in spring season, if your drained land is there, the quantity of water is present over here, this area you can see. Okay. So this root can utilize this water through the capillary action. What is capillary action? That through surface tension it takes water under tensile force. Okay. So same here, the last, that is undrained condition, full water supply. This is water level, water supply is there, and the drained condition you have this area of soil is filled with air also. So it helps for the growth of the plant. Sorry, this air. So same picture over here. Now this strata you need to understand first. So this is soil structure actually. This structure is the soil, and this this is soil particles. These are voids which are filled with the air, and these are solids particles. So okay. So here what you have, actually if you learn in the geotech, your strata, whatever your strata, your soil is, if you are partially saturated soil, it is having solid as well as water as well as air. So if your soil is fully saturated, means air is not present. Suppose you must have learned that your total volume of the soil is this volume of solids plus volume of voids. So this volume of voids is equal to volume of air plus volume of water. Is it okay? So if your air is not present over here, the volume of air is not present, then your soil is considered as fully saturated soil. Okay. And dry soil means if this water is not present over here, this volume of water is not present over here, only air and solids is present, then your soil is considered as dry condition soil. Okay. So this is a saturated condition, all pore spaces filled with water. So this is the condition of the soil when it is saturated. Fully saturated means all voids are filled with the water. This is waterlogged area. we are considering in the terms of irrigation. Now we are having many types of water in the irrigation, that is gravitational water. So gravitational water, what we have, gravitational water is free water moving through soil by the force of gravity. So suppose if you are having soil, this is soil strata, okay. If you apply water over here, what will happen? It will drain, and it will drain directly to the lower layer, okay. So this water is not utilized by the plant. This is the gravitational water, okay, drained water. So it is largely found in the macropores of the soil. Capillary water. So capillary water is if your soil is over here, so this capillary water is retained by this your soil. It is not drained. It is not called gravitational water. It is not fully drained, but it will be retained by your soil, and this water is utilized by your plant to grow. Okay. So this capillary water is water held in the macropores of the soil and is the water that compose the soil solution. Okay. So capillary water is the main water. This is very important thing. This water is the main water that is available to plants and is trapped in the soil solution. So this water is mainly used by the plant for its growth. Now we are having hygroscopic water. This is classification of water actually. Okay. So hygroscopic water, it's a very thin film surrounding soil particles and is generally not available to the plants. It is in the soil, it is present in the soil, but it is not available for the plants to grow. Okay. So this type of soil water is bound to so tightly to the soil by adhesion properties, and that very little of it can be taken up by the plant root. So what adhesion and cohesion I think I don't need to understand that adhesion. What is adhesion and cohesion actually? Cohesion means and adhesion. This is very important term you need to understand in the fluid also and the soil properties also. Cohesion means, suppose we are talking about the concrete. So concrete have many particles. Many particles means you have cement, sand, then water, then your coarse aggregate and maybe admixture. Okay. So these things, ingredients having different properties, even they bind together and form one concrete rock-like structure. So these things having cohesion properties. Cohesion properties mean different properties bind together, okay, for getting a new product. So this having cohesion properties. Adhesion properties means it is having like water, okay. So this water, what will happen in the if you consider water over here and if you consider mercury over here, so this mercury is the best example I think. This mercury having cohesive properties, and this water having adhesion properties. Like this is a glass. Properties of glass is glass, okay, and this is water. So water will try to attach with the glass, okay, glass particle is gain the shape of the glass. So this having the it's trying to attach with the glass. So this having the adhesion properties means we try to connect with the other properties. The other properties try to connect with other properties. This is adhesive. And cohesion means it don't mingle with the other properties, it get bind together, okay, that is cohesion. So here what happened? So it soil by adhesion properties means the water is having connected with the soil like adhesive nature, and that have little of it can be taken by the plant root. So the water uptake becomes zero when the wilting point is reached. This is very important. Wilting point means drying condition, means soil is getting dry. So this point is called wilting point in terms of irrigation. So the wilting point is the water content at which plant will permanently wilt. So this wilting point is the condition where the plant will not utilize the water from the soil and it will permanently dry, means it will die, your plant will going to die because of the absence of water. Now this is very important in terms of irrigation. Field capacity. What is field capacity? The amount of water in the soil after free drainage has removed gravitational water after 2 to 3 days. Means suppose you have entire land over here, this is this soil strata, you are applying water over here, okay. So what happened, it will try to have adhesive properties with the soil and the extra water will going to drain in the lower layer. So the amount of water retained by this soil is actually the field capacity of the soil, the amount of water it can retain, the maximum amount of water it can retain, that is capacity of the field. So it is denoted by field capacity, okay. So after removing his gravitational water, extra water, gravitation means extra water, the water retained by the soil itself is called gravitational water, is called field capacity. This field capacity is the amount of water that this well drained soil should have, should hold against gravitational forces, okay. So soil having holding maximum amount of water available to plants, optimal reaction, macropores filled with the water, macropores with air. So this aeration means it's filled with air and water. Measuring soil moisture. So we have some instrument we can measure the moisture. So this can be indirectly measured by device and instrument. Example, one tensiometer we have, we can measure directly the soil moisture, resistance block or nutrient props. So direct measurement of soil moisture can be by weighing or gravimetric method. So direct, this is indirect method, tensiometer, and direct method we can have by weighing the soil. For example, in oven dry test, what we do, we will weight the soil, moist soil as W1, then we will allow to dry it as W2, and what we will do, if we dry in the oven, and this W2 minus W1 means dry minus wet. So we can have this moisture content, how much moisture content we will get. So this is direct method and tensiometer is the indirect method, okay. So this is a picture of tensiometer. Actually this whatever I have taught you, the definition of wilting point, then field capacity, this in the diametric view, this is present over here. This is soil water content. So this is saturated soil. Saturated soil means if your water is filled over the entire area, then this is called your saturated soil, okay. Now field capacity means the extra amount of water is drained over here and the amount of water retained by this portion is called is a field capacity, okay. Then this is available water. So this is available water and the extra water is unavailable water. Water is present over here, but it is considered unavailable, means it is not utilized by the plant and it is nothing but your gravitational water. It is your gravitational water, okay. So this point is called permanent wilting point. If the water is dry over this area, then your plant is going to start drying, means it's going to die, okay. So this is the condition. Saturation means earlier told you that your entire voids is filled with the water. Here this field capacity, air also is present over here, and this is permanent wilting point, means everything dry over here, no water, no air. This is same things they have told. This is saturated soil, means filled with water. This is field capacity, means this white portion is nothing but air, okay. Permanent wilting point means this is with air only, no water is present. So it is, you can see over here your plant is going to die now, it's become yellowish color, this is green color. So is your plant is healthy. This is in the 3D view. This is a presentation of this diagram only. This diagram I have shown you is a 3D view of this diagram, like this. So, this is field capacity. Here your water is available in this area, and this is permanent wilting point. Here water is present but it is not utilized by the plant. Okay, root zone depletion, evapotranspiration, this all process going to take. Evapotranspiration means so evaporation and transpiration both, evaporation from the intermediate layer and transpiration from the plant. Okay. So, this is water used by the plants. Okay. Now, this is depth of irrigation. Depth of irrigation is also very important. This is depth of readily available moisture. Now, it is very important that you must have seen over here your available water. Okay, this area, this is available water. But in this available water also, this plant can utilize 70 to 75% of water. Less 25% can't be utilized by the plant. So, this 70 to 75% of water is nothing but readily available water. So, this is the depth of readily available moisture. This is the net depth of water normally needed to be applied to the crop during each irrigation. We are in the this numerical part we will going to continue in the next lecture. Thank you.